So we begin the class with the technological innovation and new media. So in this class we discuss about the int services and differentiated services and intensive approach, and then we discuss about the MPLS, okay, multi-protocol label switching. So once again, this is especially for you, my dear students and young researchers, and you can reach me at dr.christoananth@gmail.com. So before beginning the session, let me thank God for giving me this opportunity to deliver this useful session to share my knowledge among my fellow national, international participants, students and young researchers. So we discuss about int services or maybe integrated services. Then we initiate the call setup process about the various service classes. Then we discuss about resource reservation protocol RSVP. Then we discuss about an example scenario for this resource reservation. Actually, we have another one example also for the resource reservation protocol. So that is the way we discuss with the video conferencing application. Okay. Then in the second part of today's class, we discuss about diff services or maybe differentiated services. Then we discuss about multi-protocol label switching header and about the various important terms which are used in MPLS. Then how the forwarding take place in MPLS. So that we will be discussing. So I've already given the independent work for you. Please complete them at your best available time. Again, I'm reminding you that there is only 1 month left. Okay, just 1 month left. So please complete your 5 independent works and your open-ended project work. Okay. So at regular intervals, I'll be giving you some videos to discuss the knowledge in our topics. So this is INSERV. It's actually a framework which is established by the Internet Engineering Task Force. So maybe to provide specialized or maybe individualized quality of service guarantees, you can apply for the individual application sessions. Okay. So there are two features which lie in the case of INSERV. So we have like reserve resources. Okay. So here the router will be having like an amount of resources like buffers or maybe link, okay, or maybe bandwidth even, that is reserved for the ongoing sessions. Then you have the call setup procedure. So maybe it is a session dedicated especially for the quality of service guarantees. So maybe for reserving sufficient resources for each of the network router on the source to destination path, generally you will have the call setup procedure to ensure that the end-to-end or maybe peer-to-peer quality of service requirement is actually met. So for the call setup process, we have like traffic specification, okay, and request specification even, okay. So for the characterization and specification of the desired quality of service, we use T-spec and then R-spec. T-spec, it is going to characterize the traffic which the sender will be sending across the network. So we will have the standard to be RFC 2215. Okay. Then for the R specification, it is nothing but characterizing the quality of service requested by the connection. Okay, so it is RFC 2210. And maybe you can use the signaling procedure even for the call setup. Like the session, you will have both the T spec as well as R spec that can be carried over by the intermediate routers, nothing but the resource reservation protocol. And for each of the call admission, we will have the per element. Okay, so that is nothing but the router is going to receive the T spec and the R spec for a particular session. Then it will determine whether it can admit the call or maybe it will not admit the call. Okay. So this is the quality of service call signaling setup. Okay. So it sends a request and accordingly it will be getting the reply accordingly, and then it will be sending on, okay, the quality of service call signaling setup to the respective computers. So there are service classes. In the case of integrated services, we have two major service classes. One is nothing but guaranteed quality of service, and another one is control load network service. Okay. So for the guaranteed quality of service, we have the standard RFC 2212. Okay. So generally it will be providing some firm or maybe mathematical bounds on the queuing delays that is provided that the packet will experience in a router. Okay. So the source is actually traffic characterization, which is given by this leaky bucket. So it will have the parameters R and then B. Okay. So here the requested service is characterized by the transmission rate, which is nothing but capital R bits per second. Then you have control load network service. It is nothing but the service approximate the quality of service that same flow would receive from the unloaded network element. That is the reason you say that control load network service. So unlike the guaranteed service, here in the control load network service, there is no quantitative guarantees which are made. Okay, so it means that it is non-quantifiable. Here we have the resource reservation protocol. So generally it will allow the applications for reserving bandwidth for each of the data flows. And for this one, it should be the software, the RSVP software should be there in the sender, in the receiver, and in the intermediate routers also. So just as you see in the diagram, we have R1 and then R2 and then R3. Here we will have the reservation pair, and then the path error function. Okay. So maybe from router 1 to router 2, router 2 to router 3, across the network it will be flowing. Okay. So you are sending, okay, the request here, and you are getting the reply across the reservation pair, reservation error event. Similarly, across the routers, okay, you will be getting, you will be sending an alternate path R1, R2, and then R4. Okay, so here path there, reserve configuration, and then reserve error. Okay, so it is going to provide reservations for the bandwidth in the multicast trees, and maybe it is receiver oriented, which means that the receiver of the data flows is going to initiate and it is going to maintain the resource reservation used for that flow. So these are the resource reservation protocol. We have like data flow, merge reservations, okay, which is going on. Here the reservation message is sent by the computers across the routers. So the merge reservations is once again cumulatively growing to the entire network. So there are some definitions that you should know, like there is some session. A session can consist of multiple data flows, and every sender in a session will be a source of one or maybe more data flows. Okay. So every data flow in that particular session has the same multicast address, and it is identified by the flow identifier field IPv6. So resource reservation protocol, there are some characteristics which it does not do. It does not specify how the network will provide the reserved bandwidth to the corresponding data flows, and generally it is merely a protocol that allows the applications to reserve the necessary link bandwidth. And definitely this resource reservation protocol is not a routing protocol, but definitely, and also it does not determine the links in which the reservations are to be made. So this is the example scenario. We have like R1, R2, R3. Okay, so we have the rate 20 Mbps, 100 Mbps, 3 Mbps that is being sent across 20, 100, 100 from here. Okay, 3 from here. Okay, so it is sent across the routers even to the source, back to the source. So the source is transmitting maybe a sports event, maybe video and then audio. So here it will be using layered coding to handle not homogeneous but heterogeneous receivers. So here in the reservation protocol, it is receiver oriented reservation protocol. Then you have an example for video conferencing. So this is from the sender, okay, from A, B, okay. We have sender receiver at all the ends. We have A and B, okay. So here every person maybe has 3 windows open to look at 3 others. Everybody can look at others, okay. So every person wants to see each of the video maybe like at 3 Mbps. This is the data rate we are spending. And resource reservation protocol, since we are able to see, or if you want to see 3 Mbps, resource reservation protocol will be reserving 9 Mbps in one direction and maybe 3 Mbps in the other. And here no merging will take place because every person wants to receive 3 distinct streams. Okay. And maybe for the audio purposes, maybe like suppose we are requiring B BPS, okay, for each data stream. So maybe it is very rare, maybe like 2 persons to talk at the same time. Okay, not really necessary that you have to reserve 3 BPS into each receiver. Maybe maybe if 2% speak means okay, two times the bandwidth BPS. Definitely it will be sufficient, not 3 times. Okay. Next, we will have differentiated services. So there are difficulties which are associated with the integrated service model for each per flow reservation of resources. So we tend to maintain or maybe measure the scalability. So here intermediate routers have to maintain per flow state. Okay. So it was observed that the backbone router will be using the optical communication OC3 speed link, which definitely visualizes 256,000 source to destination pairs in just 1 minute. Okay, and it does not measure or maybe it does not scale, but it's a flexible service model. Okay, and IntServe generally provides smaller number of pre-specified service classes even, and generally you can use this or maybe you can require this for the qualitative or relative definitions of the service classes. So this is a architecture for providing scalable or maybe measurable and flexible service differentiation in order to overcome the disadvantages. Okay. So we are going to handle different modes of traffic in different ways across the internet. Okay. So you'll have the edge router, then we have the sources. Okay. So it is being connected to the core router. So this one is the differentiated services domain. Okay. That is being connected to the edge router. Okay. And to the host. Okay. So CR is nothing but the core router, okay, differentiated services control point switch, okay, and then differentiated services control point assignment that you are going to specify in the edge router. Okay, so these are the edge routers. So differentiated services architecture will be having some functional elements like here if you can see you have edge routers, you have edge functions that are associated. Here you will be doing the edge classification and then traffic conditioning, and then the core function it is just used to forward. Okay, so this is MPLS multi-protocol label switching. So it's actually an internet protocol packet routing technique which is going to route the IP packet through the paths across the labels instead of looking at a complex routing table of routers. Okay, so generally it will be increasing the delivery rate of the internet protocol packets, and generally MPLS or maybe multi-protocol label switching will be using layer 3 service. So that is nothing but the IP internet protocol, and maybe it will use the router as a forwarding device. So just as we saw in the last diagram. So traffic of these different customers is separated from each other because this multi-protocol label switching will be looking like a virtual protocol network. Okay. So it does not work like a regular VPN, but maybe somewhat similar. It is going to encrypt the data, but it ensures packet from one customer that cannot be received by another customer. So maybe the MPLS header is added to the packet that lies between layer 2 and layer 3. So that it will consider to be layer 2.5 protocol. So this is the MPLS header. We will be having 4 paths: label, EXP, bottom of the stack, and then time to live. Okay. So label, it's actually 20-bit long. Okay. And generally it can have the values between 0 to 2 power 20 minus 1. Then EXP, it is actually 3 bits long, and generally for the quality of service purpose you can use it. Then you have bottom of stack, it is actually 1 bit size, and MPLS labels are stacked one over the other. Maybe if there is one label remain that in the MPLS header, then that value is equal to 1, otherwise it will be 0, like binary value. Okay. And then time to live, it is 8-bit long in size, and generally its value is decreased by 1 at each hop to prevent packet to get stuck in the network. So this is the layer 2, layer 3, layer 2 data link layer, layer 3 is internet protocol, MPLS header. Okay, so you will have 20 bits for label, 3 bits for EXP, 1 bit for BOS, and 8 bits for time to live. So we have some terms which are associated with the MPLS. Here you have provider edge router. Actually, we discuss about edge router. Provider edge router we'll be discussing. So this is the router at the edge of the multi-protocol layer switch network. Okay, that is going to add or maybe remove the label from the IP packet. Then you have customer edge router. So router at the edge of the customer network that sends or maybe receives IP packet from the provider edge router. Then you have label switch router, LSR. So routers used in this MPLS network which can understand the labels, or maybe which can understand the relationship between the labels. Then you have ingress label switch router. So label switch routers which receive the IP packet from the customer edge router, and it's going to add the MPLS header. Then intermediate LSR, so it is going to swap the labels in the MPLS header, and generally for forwarding the labeled IP packet you can use the intermediate LSR. Like ingress you have egress, okay, that is opposite, okay. So that is going to send the IP packet to the customer edge router, okay, and it is going to remove the MPLS header. Then you have push, pop, and then swap. Maybe like the same the case of data structures, like adding, removing, and then swapping the labels by the label switch router. Then forwarding takes place, like the LSRs receive IP packet with the CE and then adds the MPLS header in between the layer 3 and layer 2, and which means that it is going to encapsulate the link layer 2, okay. So which means that it is going to allow LSR to support receiving packets containing frames with the case of frame relay or maybe metro ethernet, okay. So that is the reason you call it as the multi-protocol layer switch, okay. So here MPLS forwarding is based on the label which is attached to the IP packet, and generally you will have this label attachment to be label distribution protocol, LDP, okay. So every LSR is going to learn the routes as like the normal routers do, and generally it will be starting out with the provider edge router, okay. So every provider edge router is going to learn the routes to the different subnets from the customer edge router, and supports, let us take in the case PE router with PE1 learns route to the subnet from the CE router. Then it will be adding the label to the packet. Then it will be forwarding it to its neighbor LSR, and maybe it will be telling them if you receive the packet which destination address to the subnet one, then which means then it will forward it to the other ones. So the process is actually repeated, which means that LSR is going to learn the routes, and maybe it is going to add the information in the label forwarding information base, okay. So if any P is going to receive the packet with the destination to the subnet one, then maybe if you look at the labels, or maybe if you look at the label forwarding information base, which means that the LSR can easily forward the IP packet. So these are the customer 1, customer 2, customer 3, and customer 4. This is the MPLS network where all the 6 routers are LSR. So everything is being connected with the provider edge router.